We've been talking a lot about force, mass, and acceleration. But what's the relationship between them? Let's find out. Hello everybody and welcome. Today we'll be talking about the most important relationship between force, mass, and acceleration. So before we do that, we have to introduce some main ideas and concepts, and let's start right now. For example, let's do a quick recall that this object was not moving and now it's moving, and we know that it had an initial velocity which was 0. Now it moved, so it has a new velocity, and if the velocity of any object changes, we can say that this object is accelerating. Okay, so a question might come to your mind: what causes objects to accelerate? In other words, what can be done to make an object move? Can an object move by itself? Let's ask ourselves this question and do a quick analysis. Let's look at this ball right here. So the man right here, he strikes the ball, and because the man strikes the ball, it was not moving. Now it's moving, so it caused it to accelerate. Okay, so the object did not move by itself. It was caused to move by this man striking the object. What are we trying to get here? Well, we can say that the man was able to change the acceleration of the ball by applying a force on the ball. So there must be a relationship between acceleration and force. Okay? Now, we know that force has a unit. The unit of force is called newtons, and it's named after the very famous scientist Isaac Newton, who we will be studying about his famous laws in detail later. So to summarize, we said that no object can accelerate if there was no force applied on it. Now we can say that forces come in many shapes and forms, and they can be categorized into two main types. The first type is called contact forces, and the other type is called non-contact forces. What's the difference between them? Well, actually, we can simply say that contact forces, they need direct interaction between the object and the force. For example, when you push something, when you pull something, when you kick something, this is applying a force by touching it. Well, can we apply a force on something without touching it? Well, actually, yes, that's in non-direct forces, where there's no direct interaction between the object and the force. For example, magnetic fields and electric fields. These are types of forces that do not need any contact. So later in this chapter, we will cover many types of contact forces, and we will be talking about more non-contact forces when we talk in the next chapters. Okay? Now we need to cover a very important term called inertia. So sometimes a question comes to your mind saying that, why is it easier to push a shopping cart than to push a normal cart? Well, the answer is simply inertia. So inertia is an object's resistance to change in motion, because objects do not like to change their motion. So a moving object likes to remain moving, and a non-moving object likes to remain not moving. So objects normally resist their change in motion. Okay? Now, the higher the inertia of the object, the harder it is to move objects. Okay, so now we're trying to get an understanding of what inertia is. Now, okay, we know that it's the resistance to change in motion, and the higher the inertia, the harder it is to move an object. Okay, but what makes the inertia of the object higher or lower? Okay, we understand the concept of inertia, but how can we increase the inertia of an object? How can we increase its resistance to change in motion, or how can we reduce its resistance to change in motion? Well, the answer is simply mass. There's a very direct relationship between inertia and mass. Well, are they the same thing? No, they're not the same thing, but inertia is very much affected by mass. Okay, but what is the relationship between inertia and mass? First of all, we need to do a quick reminder that the SI unit of mass is kilograms, and mass does not change with the location of the object. It's very important to know this and keep it in mind, that masses of objects are always the same. For example, on Earth, the mass of the object will remain the same. On the moon, the mass of the object will remain the same. And even if you're floating in space, the mass does not change. Masses of object do not change. Well, yeah, it's clear. We know that. But why are you telling us that? Because later on, we'll be covering something called the weight, and weight is changing, etc. We're not going to go into details right now. So I really just needed to remind you that the SI unit of mass is kilograms, and masses of objects do not change. Okay, so let's go back to our original question. What's the relationship between inertia and mass? Let's look at this ship right here. It has 2 people on it, and this ship right here has like 5 people on it. So we can say that the mass of the first object or the first ship is lower than the mass of the second ship. Well, because the mass of the first ship is lower, we can say that it is easier to increase its speed because, it has a lighter mass. Yeah, it's common sense. We understand that. Well, it's not just because of mass. Well, here it's because of inertia, because we said that inertia, it's the resistance of objects to move or change their motion. So lower mass means it's easier to change its motion, so it means it has lower inertia. While this object here has a higher mass, therefore it's harder to increase its speed, and we can say that it has higher inertia. So we can say that mass or inertia and acceleration are inversely proportional. Let's go into more details about that so we can fully understand it. If we look at this graph, it will show me the relationship between inertia and mass, and inertia with acceleration. So let's look at the first one. Look here, we're talking about the relationship between acceleration here, and in the x-axis we have inertia. Okay, so it's clear that the higher the inertia of the object, the lower the acceleration, and vice versa. So this means that the relationship between acceleration and inertia is inversely proportional. While if we look at the relationship between mass and inertia, see, it's clear that the higher the mass, the higher the inertia. So we can say that inertia and mass are directly proportional. So inertia and acceleration are inversely proportional, while inertia and mass are directly proportional. That's what I wanted to introduce before we go into Newton's laws. We know now that the relationship between mass and inertia, it's clear. And we know the relationship between acceleration and force. No object can accelerate without a force applied on it. So that's an introduction to what we're going to say from now on. Stay tuned in the next videos. We will be introducing Newton's laws. See you then.